So let's look at chain rule hack 1. Say we have this question. Find the derivative of x squared plus 1 to the power of 4. So all we have to remember is that the derivative of f of x to the power of n equals n times f of x to the power of n minus 1 times the derivative of f of x. So in this question, our f of x is x squared plus 1, and the derivative is going to be 2x using the power rule. And then all we have to do is put this information into the equation. So to solve this, we're going to go 4 times f of x, which is x squared plus 1, to the power of n minus 1, 4 minus 1, which is 3. And then we multiply this by f dash x, which is 2x. Now we can simplify this. So 4 times 2 is 8x. And then x squared plus 1 cubed. All right, now let's look at hack number 2. Say we want to find the derivative of e to the power of x to the power of 4. Now the hack that we want to remember for this is that anytime we have e to the power of f of x, its derivative is always e to the power of f of x times the derivative of f of x. So in this question, our f of x is x to the power of 4, and its derivative is going to be 4x cubed using the power rule. So now all we have to do is put this information in our equation. So that's going to be e to the f of x is just e to the power of x to the power of 4 times its derivative, which is 4x cubed. And we can simplify this, and it will become this. All right, let's look at the next hack. Find the derivative of ln x cubed plus 2x. Now, again, this is quite simple as well. All we need to remember is that when it's ln of f of x, its derivative is always f dash x over f of x. So in this question, our f of x is x cubed plus 2x, and its derivative found using the power rule is going to be 3x squared plus 2. So the derivative, which is f dash x over f of x, is going to be 3x squared plus 2 over f of x, which is x cubed plus 2x. Now let's look at hack number 4. Say we want to find the derivative of sine of e to the power of 2x. Now the hack is, anytime we want to find the derivative of sine of f of x, it becomes cos of f of x times the derivative of f of x. So in this question, our f of x is e to the power of 2x, and its derivative using our hack 2 is going to be 2e to the 2x. And then we just put this information into this equation. So that's going to be cos f of x is e to the power of 2x times f dash x, which is 2e to the 2x. And then simplifying this, we're going to have 2e to the 2x times cos e to the 2x. And that's it. Let's look at the last hack. Anytime we want to find the derivative of cos of f of x, what we need to do is it becomes negative sine f of x times the derivative of f of x. So in this case, our f of x is x to the power of 8, and its derivative will be 8x to the power of 7, found using the power rule. Now let's put that information into this equation. So this is going to be negative sine f of x, which is x to the power of 8, multiplied by the derivative, which is 8x to the power of 7. And if you simplify that, that will be 8x to the 7, negative 8x to the 7 times sine of x raised to 8. And that's it. So let's do a quick summary. Anytime we want to derive f of x to the power of n, we use this equation. Anytime it's e to the power of f of x, we would use this. When it's ln of f of x, then we would use this equation. When it's sine of f of x, it becomes this. And when we're deriving cos of f of x, it becomes this. So a quick hack for that as well. If you write this out, anytime you derive, you go downwards. So for example, when you're deriving sine, its derivative becomes cos of something. And anytime you're deriving cos, its derivative becomes negative sine of something.